So we have been talking about standard deviation and variance. And so what we're going to do now with our example 3 is just, again, go through, enter our information on our calculator, and then talk about how to find the population, variance, and standard deviation. So what we want to do is first go through, right? We'll read the question. It says the values below represent the number of points scored per game for every game in the Arizona Cardinals 2015 season. Use your calculator to find the population, variance, and standard deviation. So our first thing that we want to do is go into our calculator and enter our data. So remember to do that, we hit our stat button, our edit, and we want to clear anything out. So I had some data in here before. So L1 and hit clear. And then I want to go through and enter in my data. Remember, it really doesn't matter. I'm just going to go by rows. So 48, 47, 22, 42, 13, 26, 34, 39, 34, 19, 27, 23, 40, 38, 6, 26, and 15. Okay. So once I have everything entered, we are going to go back to our stat button. We're going to arrow over 1 to calculate, and we want the 1 var stat. That's going to tell us all the variables. So we looked at using L1 and L2 previously. We just want L1 since that's where my data is in. So we'll arrow down to hit calculate. And so we have a bunch of different things. If had it asked for the mean, that would be this first one here, roughly 29.4. It's asking, it says the population, variance, and standard deviation. So for our case, right, our population standard deviation in our calculator is this sigma. So I'm actually going to write this whole thing down. So sigma x, this is the standard deviation. So 11.53363305, right? So I write it down because in order to get the variance, we have to take that whole number and square it. So our calculator doesn't directly give us the variance, but we can calculate it. So I have my standard deviation, which for the population is just sigma. So 11 point roughly 5. And so in order to find my variance, which is sigma squared, we're going to take that whole number that we wrote for sigma sub x and type that into our calculator. So 11.53363305, and we're going to square that, and then we'll take that number and round it. So we would have, my variance would be 133 roughly 0.0, so 133, and that would be my variance. So again, as long as I have my data, I can enter that into my calculator and figure out the variance, standard deviation, and even the mean and median if I needed that. So let's take a look at one more idea in our section. It says one of the uses of standard deviation is to determine how unusual a particular data value is. If a data value is within, so we say 2 standard deviations, then that value is a common data value. If the data value is outside 2 standard deviations of the mean, either above or below, then the number is uncommon, and it would even be called, we usually say it's unusual. So anything that's greater than 2 or less than -2 would be unusual. So what we'll come to find out with our standard deviation, so I have 0, I have 1, -1, -2, and 2. So anything within this region here, I guess I should put a bracket there because we do include the -2. This is usual. And so anything outside this, right, so anything this way, so anything in the pink and this way, we call unusual. So let's take a look at how we can use this to determine if something is usual or unusual. So use of standard deviation. It says one of the uses of the standard deviation is to describe how a population is distributed and how unusual a particular observation is. A rule of thumb that can be followed is that if a data value is within 2 standard deviations, then that value is a common data value. If the data value is outside 2 standard deviations of the mean, either above or below, then the number is uncommon. It could even be called unusual. An easy calculation that you can do to figure it out is to find the difference between the data point and the mean, and then divide that answer by the standard deviation. As a formula, this would be, so x minus mu over sigma, and this we usually say, it's not written in our formula, but we say z is equal to this. So if you don't know the population mean and the population standard deviation, then use the sample mean and sample standard deviation as to estimate the population parameter values. So for example 4, it says suppose a passage of play in a rugby game takes 75.1 seconds. Would it be unusual for this to happen? Use the population mean. So my population mean, so mu, is 32.1 seconds, and a standard deviation right about the population, so that would be sigma, is 18.5. So this initial 75.1, that's my data piece. So we want to find the z-score. So my z-score would be x, right? So x minus mu over sigma, which in our case would be 75.1 minus 32.1, all divided by 18.5. Now, when we're entering this into the calculator, we do want to make sure we have parentheses around that numerator there, so I calculate the correct value. So 75.1 minus 32.1. So close that off and then divide that by 18.5. So this would give us a z-score, so 2.32, right, roughly. So this value is 2.32 deviations from the mean. And so since it's above, right, it's farther away than 2, we would say this is an unusual value because it's outside that 2.